Okay, MCT4C lesson 1.4b. This is part 2. We're on to example 3, I believe. Godzilla is standing on top of a building from 35 meters away. The top of the building has an angle of elevation of 30 degrees, and the top of Godzilla's head is 42 degrees. Again, 30 degrees, there's one of our special angles. I see we're going to need our calculator anyway, so maybe we can just use our calculator there. That should be fine. But diagram, let's get it going with the diagram. Ground, the building there, Godzilla, green blob of some sort, right? Tail. There, good Godzilla. Handy. Now what does it say? From 35 meters away, so from 35 meters away on the ground here, 35 meters, the top of the building has an angle of elevation of 30 degrees. So from 35, there's the horizontal, and we're going to sweep up to the top of the building. That angle is 30 degrees. So let's write that in there. 30 degrees there. And the top of Godzilla's head is 42 degrees. So from the horizontal, 42 degrees. There, 42 degrees. How tall is Godzilla? This is what we want to find out right here, just this much. Of course, maybe there's something in this triangle we could do, but we haven't done any of the sine law, cos law, all that other stuff. We have to use right angle triangles, and how we're going to do that is by finding the height of the building, call that B for building, and the height of both. Right there, I'm going to call that Y. There. And to get the height of Godzilla there, all I'd have to do is find Y and subtract B. But that's going to take a little bit of work, so let's get at it. In this small triangle, the one on the bottom here, I can see I've got the opposite side and the adjacent side's 35. Opposite and adjacent, that's the tan of 30 degrees, is B over 35. Multiply by 35. And we get, fire that into a calculator, or we could look it up and be exact, but we're going to subtract it from an approximate answer later anyway. So about 20.2 meters, and that seems about right. So now let's find the height of both of them. That's in this big triangle here. In this one, both the building and Godzilla together, the 42 degree angle is Y over 35. Opposite over adjacent's 35. Same calculation, different numbers. And we get about 31.5. Check that on your calculator. I've been known to make some mistakes. That seems about right, because now to get just the height of Godzilla X here, I'm going to subtract the two, right? Maybe I should do that in green for Godzilla, right? That makes sense. X is just 31.5, subtract 20.2, which is about 11.3 meters. So therefore, Godzilla is 11.3 meters tall. And on we go. Now, these ones are actually fairly tough and new to our course. This is the idea of this problem is solved in 3 dimensions instead of 2. In the last question, sort of Godzilla and the person making the measurements in the building were all in one plane, in one triangle. In this question, we see to find the height of the cliff, okay, that's kind of like Godzilla, but how in the Earth could we ever find what this length is in order to get this length? We can't find out how wide the river is, so we have to do another measurement. This one is sort of a triangle that's lying flat on the river. So part A is to find this length here, BY. BY is the width of the river. And so this side here, well, in this triangle that's flat on the surface of the river, I've got need the opposite side, have the adjacent side. That's the tangent again. Very useful, the tangent, isn't it? I'm going to say that's BY over 18. Same calculation, eh? 18 tan 48. Jam that into a calculator, and we get about 20 meters. Then in the next question, the height of the cliff, now that we've got that 20 meters, this is 20 meters now, then I've got the adjacent side to this 41-degree angle, and I can find CB, the height of the cliff. All right, so again, opposite and adjacent is the tangent. Same calculations, right? Use a calculator, and that's about 17.4. Oops, done. Next. Another three-dimensional one, right? This is a three-dimensional object. A grain shelter, square base pyramid. So this is 6, square base, 6 meters. Determine the height of the pyramid. So the height of the pyramid, there's actually two heights into these three-dimensional objects. One's the height of the pyramid itself. I'm going to call that H. One of them is a slant height. The slant height's given there is 4.2. How we find the height, if we look at that triangle sort of in the middle of the grain shelter, the height is one of the sides we want to find. There's this length, which we actually know, and then the slant height is the hypotenuse of that triangle. What's this height? Well, if I were to extend this all the way, this is 6 all the way across. So this has got to be halfway across, which is 3. The diagram's not perfect, but that's 3 meters. And so now, part A, 4.2 squared, 8 squared plus 3 squared, 9. I'll put that in our calculator in one step. Why not? What do we got? That's 8.64 square root of that. The height is about 2.9. I think we need that in the next one. The volume of the shelter. Well, I mean, I don't expect you to have the volume formula off by heart. We'll do some measurement and geometry stuff later in the course, but I'll give you the formula now. The volume of this shape is the side squared, call it base squared, times the height divided by 3. And that's anything that comes to a point we divide by 3. Maybe you remember that from previous grades or not. The base is 6. The height was the 2.94 that we just found. And then fire that into a calculator just as fast as we can. Times in between there. I'll put that in brackets maybe so we know to multiply. Divide by 3. 6 squared times 2.94 divided by 3, all in one step in our calculator. We get 35.28. And the units, volume in meters cubed, The volume is 35.28 meters cubed. Part C, we want to find the angle, sort of the pitch of this crane shelter. Running out of room a little bit, but we should be okay. Here, in this triangle, we could use either, we've got all three sides, so it doesn't matter which one we use. I'm going to use the adjacent side and the hypotenuse that we were given. Again, the idea is when we can avoid using calculated values to get new calculated values, that's a good idea. So we got cos theta, adjacent is 3, hypotenuse was 4.2, and then this is easy as can be, isn't it? Do the inverse cos of both sides, jam that into a calculator, and you get what type of angle? Looks like about 44 degrees. And that is it for today.